All right, guys, so now we are going to try to work on this section 4.2, page 257. And it is all about dividing polynomial. And there is different way to divide a polynomial, the long division and the synthetic division. We are going to try to solve many problems. And it's just a question of paying attention what you're doing. So let's try to do, first of all, problem number 1. So in this problem number 1, we have 10x to the 6 over 5x cubed. In that case, remember that a times b over c times d, it's the equivalent of a over c times b over d. It could be also a over d times b over c. So in that case, I'm going to have 10 over 5 multiplied by x to the 6 over x cubed. 10 over 5, it's 2. And x6 divided by x cubed. You have different way to do it. You can have x divided by 3x. And so obviously the x divide out and at the end you got x cubed. Or you could have x to the 6 multiplied by x to the negative 3 because 1 over x cubed equal x to the negative 3. And x to the 6 times x to the negative 3, it's equal to x to the 6 minus 3. And so it's going to be equal to x cubed as well. So the answer is going to be for this one, 2x cubed. I could do exactly the same thing for problem number 3. And this problem number 3, what do we have? We have 8x to the 9 over 3x to the 7. So we have 8 divided by 3, nothing that I can do about this one, and x to the 9 over x to the 7. X to the 9 over x to the 7, it's equal to x to the 9 multiplied by x to the negative 7. That should remind you a to the n times a to the m equal a to the n plus m. So therefore, I'm going to have x to the 9 plus negative 7, and the answer is going to be x squared. And therefore, finally, I'm supposed to have 8 over 3 x squared. Now, if I look at the problem number 6, on the problem number 6, this time we have 5x cubed plus x squared over 3x squared. We have two terms on the top and one term on the bottom, so that could be written as 5x cubed over 3x squared plus x squared over 3x squared. And obviously now you will agree with me that it's going to be 5 cubed, 5 over 3x plus 1/3. Why? Because x cubed and the square, and then I still have 1x, and x squared divided with the x squared, and now we have 1/3. Same idea with problem number 8. Problem number 8, 7x to the 8 minus 6x cubed over 6x squared. It is a 7 over 6x to the 8 over x squared minus 6x cubed over 6x squared. The 6 divide out, x cubed simplify, and now I'm still have x. X to the 8 divided by x squared, it's going to be x to the 6. And so 7 over 6, x to the 6 minus x. Now, let's try to focus a little bit about the problem number 21, which is the problem regarding the synthetic division. So what I want to do is try to do a recall on when you have a polynomial p of x and you divide this polynomial by x minus k, you will end up to have a new polynomial plus the remainder divided by x minus k. So what they are telling you is find each quotient when px is divided by. So we have p of x equal x cubed plus 2x to the square minus 17x minus 10 and divided by x plus 5. So we are looking at the division of x cubed plus 2x squared minus 17x minus 10 by x plus 5. What I would do is I'm going to do two things. First of all, I can do the long division, and I can do the x plus 5 divide x cubed plus 2x squared minus 17x minus 10. When I do my long division, step number 1, I take the first term of my polynomial, which is x cubed, and I divide by the first term of x plus 5, which is x, and that gives me x squared. So I will have x squared right here. X squared multiplied by x give me x cubed. X squared multiplied by 5 give me plus 5x squared. You will notice that there is a decreasing exponent, cube, square, 1, x, it's x to the 1, and no exponent because there is no x. And so therefore, when I do the long division, I must remember I'm always subtracting. And so when I'm subtracting, I end up to have minus 3x squared. I bring down negative 17x, and I repeat the same process. The first term of my line, minus 2x squared, divided by the first term of x plus 5, which is x. The answer is going to be negative 3x. So now I'm going to have negative 3x right here, and I distribute negative 3x to the x plus 5. That is going to give me negative 3x squared minus 15x. And again, I must subtract, so I am going to subtract. Because on the long division, I'm always subtracting. And so when I'm subtracting, I end up to have negative 2x right here. I bring down the negative 10, and again, negative 2x divided by x give me negative 2. I put negative 2 right here, and so I distribute negative 2 to the x plus 5, negative 2 by x, negative 2x, negative 2 by 5, negative 10. When I subtract these two lines, I end up to have 0. That tells me two things. First of all, I would say that the polynomial p of x, which is x cubed plus 2x squared minus 17x minus 10 divided by x plus 5 is equal to x squared minus 3x minus 2. Because I find 0 at the end, that tells me that my polynomial p of x plus 2x squared minus 17x minus 10 can be equal to basically x squared minus 3x minus 2 times x plus 5. And so therefore, I can literally, from this expression, if I look for the 0 of my polynomial, meaning that my polynomial x cubed plus 2x squared minus 17x minus 10 equals 0, basically what I'm looking at is the 0 of my polynomial, meaning all the value of x that make my polynomial equal to 0. And what does that mean? It means that each parenthesis will help me to find the 0 of my polynomial. And so I can literally say x plus 5 equals 0, so x equals negative 5. That would be 1 0 of your polynomial p of x. And to find the other 0, I could do an x squared minus 3x minus 2 equals 0, using my quadratic formula with a equal 1, b equal negative 3, and c equal negative 2. I will find the two other zeros, meaning that my polynomial right here, x squared minus 3x minus 2, will be, in fact, made of two parentheses, and each parenthesis will help me to find a new value of x, who makes my polynomial degree 3 equal to 0. I'm expecting to have 3 zeros. Why? Because it's a polynomial degree 3. All right, let's try to do another one. And let's try to do problem number 29. When I look at the problem number 29, and I'm going to do the problem number 29 using my synthetic division this time. So problem number 29, we have negative 2x cubed minus x minus 2 divided by, x plus 1. So what I want to do first is rewrite that by making sure I'm having a decreasing exponent, and I need to add, therefore, 0x squared divided by x plus 1. So when I do my synthetic division, I see x plus 1, there is a plus, so I will take plus 1. If it was a minus 1, I will take minus 1. And then I'm going to take the coefficient that I read on my polynomial, and it's going to be -2, 0, -1, and -2. The first step when you do the synthetic division is to bring down the first term, and then you are going to multiply the plus 1 by -2. That gives you -2. Because you took what you saw, which is you have a plus 1, and so therefore you put plus right here. You will subtract. And so 0 minus -2 give you a plus 2. Now I continue. 1 times plus 2 give you plus 2. I subtract, that gives me -3. 1 times -3 equals -3. I subtract, and that will give me 1. And then, because I make sure that I was having a decreasing exponent, the exponent 3, exponent 2, exponent 1, and then just a number, what was -2 in blue right here, corresponding to -2x cubed, now this -2 right there corresponds to -2x squared. And now, definitely, it's going to be very easy for me, because what I'm going to do is I'm going to have a decreasing exponent, 2x squared. Now I'm going to have 2x minus 3, and therefore plus 1, because it's a plus 1, divided by x plus 1. Okay? This plus 1 right here, let me change the color. This plus 1 right here is right there. And why do I have x plus 1 right here? This plus 1 right there, coming from this x plus 1. What do I have right here? I don't have a 0. So therefore, I can literally say that x plus 1, that could be try to become x to equal 0, that could be x equal -1, cannot be equal to 0, because you don't have 0 right here. So therefore, x plus 1 cannot be equal to 0, x cannot be equal to -1, and I would end up to say that -1 is not a 0 of your polynomial p of x. Okay? I would like to do with you now problem number 35. In this problem number 35, it's all about k equal 3, or -2 in that case, k equal -2, and your polynomial p of x equal 5x cubed plus 2x squared minus x plus 5. And the question is, calculate p of k. So calculate p of -2. And when you calculate p of k, p of -2, it's equal to -25. And what does that mean? That means when x equals -2, your polynomial p of -2 is equal to -25. Well, for sure, it's not equal to 0. And it's because it's not equal to 0, because p of -2 is not equal to 0, -2 is not a 0 of your polynomial p of x. And remember, what are the zeros? Technically, they are supposed to be the point of intersection between your polynomial and the x-axis in terms related to the real zeros. All right. I will give a second part for this homework for this chapter 4.2 in a minute.